Have you ever seen a rainbow? This masterpiece of nature is due to the refraction of sunlight. You have probably noticed refraction in a number of different phenomena. For example, a paintbrush placed in a glass of water appears bent or distorted. On a hot day, the atmosphere seems to shimmer and a distant object may appear to float above the horizon. For practical uses, refraction is the key physical principle behind the use of lenses to focus light. Lenses are widely used in eyewear, cameras, and scientific instruments. Light usually travels in a straight line, but refracted light is bent. What is refraction? Refraction occurs when light rays are bent as they travel across the boundary from one medium to another medium of different density. If light enters a denser medium, it bends toward the normal, the perpendicular to the boundary. The converse also applies. If light enters a less dense medium, then it is bent away from the normal. So why does light bend like this? The bending occurs due to the wave-like properties of light. To indicate how much a light ray will refract when it goes from one medium to another, scientists use the index of refraction. A fast medium such as ice has a smaller index of refraction than a slow medium, such as a diamond that has a larger index of refraction. Because of this, the leading edge of the wave shown here in red slows down as it enters the denser medium, while the rest of the wave maintains its speed. This makes the light ray bend towards the normal. A prism will bend white light towards the normal, dispersing white light into a spectrum of colors. Different colors, corresponding to differing wavelengths of light, refract at different angles. When white light enters a prism, violet refracts more than red light. When they emerge, red light refracts more than violet, so the colors become separated. The rainbow we saw earlier is created because raindrops act as prisms to make a rainbow. Since water is denser than air, a light ray from the sun bends, is refracted toward the normal at the surface of the raindrop. The white light splits into its component wavelengths, what we perceive as colors. It is then internally reflected inside the raindrop and is further refracted away from the normal as it leaves the raindrop and enters the less dense air. So the light becomes more widely separated into the different wavelengths that we see as the colors of a rainbow. Refraction is a general property of waves. Other types of waves are seismic waves, sound waves, water waves, and all other electromagnetic waves. Although earthquakes can be disastrous, they also have a use, since refraction of seismic waves generated by earthquakes helps scientists understand the structure of Earth's interior.